You're 7 micrometers wide, a microscopic disc floating in a river of plasma. You were just born 30 seconds ago in the bone marrow, and already you're being pushed toward your first job. But here's the problem. You don't have a brain. You don't have a nucleus. You don't even have mitochondria to generate energy. You're basically a sack of hemoglobin with a membrane wrapped around it. And for the next 120 days, you're going to work harder than anything else in the human body. Right now, you're being shoved through a capillary that's 3 micrometers wide. You're 7 micrometers. The math doesn't work, but your body doesn't care. You fold in half. Your membrane stretches until it feels like it might tear. You compress into a cylinder shape and squeeze through a space smaller than your own diameter. And when you finally pop out the other side, you snap back to your normal disc shape. That's one capillary. You'll squeeze through thousands more today, and hundreds of thousands more before you die. Let's back up. You were born in the bone marrow about 2 minutes ago. Inside the spongy core of your bones, there's a factory churning out 2 million red blood cells every single second. You started as a stem cell with a nucleus, with DNA, with the ability to make decisions. Then something happened. The factory stripped away your nucleus. It removed your mitochondria. It gutted everything except the one thing you need to do your job: hemoglobin. 280 million hemoglobin molecules to be exact. That's your cargo. That's your only purpose. And the moment you were loaded up, you were shoved into the bloodstream before you were even fully formed. You don't get training. You don't get an orientation. The current grabs you and throws you toward the heart. And that's when you feel it for the first time. The heart slams you forward at 40 centimeters per second. That's faster than most humans can process visual information. You're launched into the aorta, the largest artery in the body, and suddenly, you're part of a rushing tide of 25 trillion other red blood cells, all moving in the same direction, all carrying the same cargo. Your first destination is the lungs. You arrive in the pulmonary capillaries, and your hemoglobin molecules start grabbing oxygen. Each molecule can hold 4 oxygen atoms, and all 280 million of your hemoglobin molecules lock onto oxygen at the same time. You're now fully loaded. This is what you were built for. But you don't get to celebrate. The heart is already pulling you back, ready to launch you out into the body. This time, you're headed for the tissues. Maybe a muscle in the leg. Maybe a neuron in the brain. Somewhere out there, a cell needs oxygen, and you're the delivery truck. You travel through arteries, then arterioles, then capillaries so narrow you have to fold yourself in half again just to fit. And when you finally reach the destination, your hemoglobin releases the oxygen. The cell grabs it. You pick up carbon dioxide in exchange. And then you turn around and head back to the heart, back to the lungs, back to the start. This is one trip. You'll make thousands today. You'll travel over 300 kilometers in a 24-hour period. That's roughly 186 miles every single day for 120 days straight. No breaks, no rest stops, no time off. And here's the thing, even when the body sleeps, you don't. While your owner is unconscious for 8 hours, you're still making deliveries. The heart slows down a little, sure. Maybe you're only moving 250 kilometers instead of 300, but you're still working. You're always working. You don't have a choice. That shortness of breath you feel when you stand up too fast, that's us failing to keep up. When the body suddenly changes position, blood pressure shifts, and for a split second, we can't deliver oxygen fast enough to the brain. The person feels dizzy, lightheaded. That's our fault. Or maybe it's the body's fault for demanding too much too quickly. Either way, we're the ones who take the blame. But this is just day 1. You have 119 more to go. And every single day, the route is the same. Lungs, heart, body, heart, lungs. Over and over and over. You don't get variety. You don't get new assignments. You're a delivery truck on an infinite loop, and the highway never ends. Let's talk about the route in detail, because this is where the exhaustion really sets in. You leave the heart and enter the aorta. The pressure here is intense. You're moving fast, surrounded by billions of other red blood cells, all fighting for space. The aorta branches into smaller arteries, and the arteries branch into even smaller arterioles, and eventually you end up in a capillary so narrow that you're the only cell that fits. You're alone now. Just you and the tissue on the other side of the capillary wall. You release your oxygen. The hemoglobin molecules let go, and the oxygen diffuses through the capillary wall into the tissue. At the same time, carbon dioxide from the tissue diffuses into you. Your hemoglobin grabs it, though not as tightly as it held the oxygen. Now you're carrying waste. You're a garbage truck on the way back to the processing plant. You flow into a venule, then into a vein, and eventually back to the heart. The pressure here is lower. The flow is slower. You're drifting now, almost coasting. But don't get comfortable. The heart is waiting, and the moment you arrive, it's going to slam you forward again, back toward the lungs, back to the start of the cycle. This happens thousands of times a day, and every time you're squeezing through capillaries, folding in half, stretching your membrane, snapping back to shape. Your body is designed to handle this, but it's not designed to handle it forever. After about 40 days, your membrane starts to show the first microscopic tears. This is normal wear and tear. This is also irreversible. There's no repair crew coming. You don't have the machinery to fix yourself. You just keep working, and the damage keeps accumulating. But that's still weeks away. Right now, you're just trying to survive the grind. Let's talk about what happens when the body decides to exercise. The person starts running. Heart rate doubles, maybe triples. Suddenly, you're being thrown through the circulatory system at twice the speed. The muscles are screaming for oxygen. They're burning through it faster than you can deliver it. You make your usual route, but now you're doing it in half the time. Lungs, heart, muscles, heart, lungs. Again, again, again. The body is producing lactic acid now because you can't keep up with the oxygen demand. The muscles burn. The person feels pain. And you're just moving faster, working harder, trying to meet a quota that keeps climbing. Or maybe the person climbs a mountain, high altitude, less oxygen in the air. You arrive at the lungs and your hemoglobin reaches out to grab oxygen, but there's barely any there. You leave the lungs only, half loaded, maybe 60% capacity instead of 100%. But the tissues don't care. They still need their full delivery. So you make more trips. The heart beats faster to compensate. You're working overtime just to deliver the same amount of oxygen you'd normally carry in fewer trips. The person feels lightheaded, exhausted, out of breath. That's you, failing to adapt fast enough to an environment you weren't designed for. And then there's fever. The body's temperature rises to fight off infection. Everything inside heats up. Your membrane becomes more fluid, more unstable. The chemical reactions happen faster, which sounds good, until you realize it means everything is more chaotic. You're moving through a system that's running too hot, and your own structure is starting to feel the strain. The proteins in your membrane begin to denature slightly. Not enough to kill you yet, but enough to make every squeeze through a capillary just a little bit harder. You're not built for these extremes, but the body doesn't slow down for you. If anything, when things get tough, you work harder. When the person is sick, injured, bleeding, you're the first responder. More of you get produced in the bone marrow. The factory goes into overdrive, churning out replacements, reinforcements, backup units. And all of you, old and new, keep running the same route. Keep making the same deliveries, because if you stop, the person dies. It's that simple. Around day 40, something changes. You're still working, still making deliveries, but your membrane is starting to lose its flexibility. Those microscopic tears from squeezing through capillaries thousands of times, they're adding up. Your surface proteins, the ones that identify you as a healthy red blood cell, are starting to get damaged. You used to be a smooth, perfect disc. Now you're slightly irregular. The edges are a little rough. The center is a little thicker. It's barely noticeable, but it's there, and your body notices everything. The spleen has been watching you since birth. That's its job. It's the quality control department for red blood cells. It has a mesh filter in its red pulp, with gaps that are exactly 3 micrometers wide. When you were young and flexible, squeezing through that filter was easy. Now, it's getting harder. You have to compress more, bend more, and every time you pass through, the spleen's macrophages, the hunter cells, take a closer look at you. They're checking your shape, checking your surface proteins, checking for any sign that you're past your prime. You pass inspection, for now, but you know, on some cellular level that doesn't require consciousness, that the clock is ticking. The spleen will catch you eventually. It catches everyone. By day 60, you're halfway through your lifespan, and the decline is undeniable. Your hemoglobin is still functional, but it's not as efficient as it used to be. Some of the molecules have been damaged by oxidative stress. Free radicals, the byproducts of normal metabolism, have been chipping away at your internal structure for 2 months straight. You're still carrying oxygen, but you're carrying slightly less than you used to. The difference is small, maybe 5%, but in a system with 25 trillion red blood cells, every percentage point matters. You're also slower now, not because you're choosing to slow down, but because your membrane has lost some of its elasticity. When you squeeze through a capillary, it takes you a fraction of a second longer to snap back to your normal shape. A fraction of a second doesn't sound like much, but when you're making thousands of trips a day, those fractions add up. You're falling behind, and the body is producing newer, faster red blood cells to pick up the slack. You start noticing them, the new ones. They move with an ease you don't remember having, even though you had it just 2 months ago. They slip through capillaries like it's nothing. Their membranes are pristine. Their hemoglobin is fresh. They're what you used to be, and you're what they'll become. It's a cycle. It never stops. And right now, you're on the downward slope. The roots feel longer now, not because they are longer, but because you're more aware of the strain. Every squeeze through a capillary reminds you that your membrane is weaker. Every trip through the heart reminds you that the pressure is the same, but your ability to handle it isn't. You're still working, still delivering oxygen, but it's harder than it used to be, and it's only going to get worse. By day 80, the spleen is paying very close attention. Every time you pass through its filter, the macrophages linger a little longer. They're scanning your surface proteins, looking for the markers that say damaged. You're not there yet, but you're close. Your shape has changed noticeably now. You used to be a biconcave disc, thinner in the middle, thicker at the edges. That shape was perfect for oxygen exchange, maximum surface area. Now you're becoming more spherical, rounder, less efficient. And that shape change is a red flag for the spleen. You also notice that you're getting stuck more often. In the smaller capillaries, the ones that are barely 3 micrometers wide, you sometimes have to force your way through. Your membrane doesn't compress as easily as it used to. You push, you strain, and sometimes you barely make it. Other red blood cells flow past you with ease, and you're left struggling in a space you used to navigate without thinking. This is the beginning of the end. You don't know it yet, because you don't have the capacity to know anything, but the body knows. The spleen knows. And soon, very soon, you'll make one final trip through that filter, and this time, you won't come out. Around day 100, the spleen finds you, not by accident. It's been tracking you for weeks, watching your shape deteriorate, watching your surface proteins fade. You enter the red pulp, and the mesh filter is waiting. 3 micrometers wide. You're now closer to 8 micrometers in diameter because you've lost your disc shape entirely. You're almost spherical. You try to squeeze through, your membrane stretches, and this time it doesn't bounce back. you're stuck. A macrophage approaches. It doesn't hesitate. It doesn't ask questions. It recognizes you as defective by your shape alone, by the damaged proteins on your surface, by the fact that you couldn't make it through the filter. The macrophage extends its membrane around you and begins the process of engulfment. You're being swallowed whole. There's no pain, no awareness, just a cellular process that's been happening for millions of years. You're being removed from circulation because you're no longer useful. The body has no sentimentality about this. You worked for 100 days. That's enough. Now you're waste. Inside the macrophage, you're broken down piece by piece. Your membrane is dismantled first. The phospholipids are separated and recycled. Then, your hemoglobin, all 280 million molecules of it. The macrophage cracks them open and extracts the iron. That iron is precious. The body can't afford to waste it. It gets sent back to the bone marrow, where it'll be loaded into a new red blood cell tomorrow, maybe one that's being born right now to replace you. The heme portion of your hemoglobin, the part that held the iron, gets converted into bilirubin. That's the yellow pigment that gives bruises their color. It travels to the liver, gets processed, and eventually leaves the body in bile. You're being excreted. Parts of you will end up in the intestines, broken down further, expelled as waste. Other parts will be recycled into new cells. About 90% of your components get reused. The body is efficient like that. Nothing goes to waste except the waste itself. And while you're being dismantled inside a macrophage in the spleen, 2 million new red blood cells are being born in the bone marrow. The factory never stops. The cycle never ends. Your death is so routine that the body doesn't even register it as an event. It's just maintenance, quality control, the removal of a worn-out part, and the installation of a replacement. Here's what your life added up to. 120 days of continuous work, over 36,000 kilometers traveled. That's almost the circumference of the Earth. You made roughly 300,000 trips through the circulatory system. You delivered oxygen to every tissue in the body. You helped muscles contract, neurons fire, organs function. You kept the person alive without them ever knowing you existed. And your reward? Being broken down for parts and replaced by a cell that will do the exact same thing for the next 120 days. You had no brain, no awareness, no ability to feel exhaustion or pain or pride. But if you could have understood what this existence would be, 300 kilometers a day, every day, for 4 months straight, squeezing through spaces smaller than your body thousands of times, working through sickness and exercise and fever, never resting, never slowing down until your membrane finally gave out and the spleen crushed you to death, would you have volunteered? Would any cell volunteer for this? But that's not how biology works. You don't get a choice. You're born, you work, you die, and the system continues without you. Right now, inside your body, this is happening to 25 trillion red blood cells. They're all running the same exhausting marathon. And every single second, 2 million of them die, just like you. 2 million more are born to replace them. The cycle doesn't stop. The deliveries don't stop. The work doesn't stop. The next time you feel tired after an 8-hour shift, remember this: your red blood cells just finished day 87 of 120. They have 33 more days to go. 0 breaks, 0 sick days, and death waiting at the finish line. Makes your job look pretty reasonable by comparison. That's the life of a red blood cell. No glory, no recognition. Just 120 days of relentless work in the dark, squeezing through impossible spaces, carrying oxygen you'll never use, keeping alive a body that will recycle you without a second thought. And then it's over, dismantled, repurposed, forgotten. If this look into your own biology fascinated you, hit the like button, drop a comment and tell me, what's the longest you've worked without a break? Because these cells work 120 days straight with absolutely 0 downtime. I'm planning a follow-up on what it's like to be a white blood cell. Same body, completely different nightmare. You won't want to miss it.